All right, we're going to look at example 2 now. So we've done this by hand, and now we're going to look at this example and use Excel to solve it out. So again, we've written out our linear program, which has 3 parts: define the variables, define the objective function, and define the constraints. So now with that, we are going to set up our optimization problem in Excel. Okay, so first we need to find x1 and x2. So I'll highlight those. Now I'm going to set this up a little bit different than I did that last one. Well, you can't quite see that, can you? There we go. So I've defined x1 and x2. And so we're going to set this up a little different. So my objective here is to minimize my cost function. Well, how much does x1 cost? Well, we know that x1 costs 12 and that y1 costs 20. And so my cost function is going to be this one here. I'm going to highlight this a slightly different color. And this is going to equal to 12 times x1 plus 20 times x2. Okay, now one thing I'm going to do is I'm going to anchor the x's here. So I'm going to have my 12 times x1, and the x1 is anchored. My 20 times c3, which is my x2, and have that anchored. The reason I do that is when I set up my left-hand side, I want to look to see what are the phosphates that are required, about the potash that's required, as well as the nitrates. If I can spell these nitrates, it's getting close to Halloween when I film this, so nitrates would be nice. Trick or treat. And so what I want to be able to do now is to say, well, x1 provides, each unit of input 1 provides 3 units of potash, or phosphates, 4 from potash, and 14 from nitrates. Well, each input of, or each unit of the second input provides 9 units of phosphates, 6 of potash, and 7 of nitrates. And so now I have my left-hand side and my right-hand side. Well, my left-hand side is 3 times x1. Well, I can just copy and paste this down. And because I anchored it, it copies and pastes exactly how I want it. If you don't anchor it, it won't be quite correct. Now my right-hand side is 45, 48, and 84. And so now I can come into Solver. My objective is to take my cost function, minimize it by changing x and y, and adding the constraint that my left-hand side is now greater than or equal to my right-hand side. Click OK, I click Solve, and I get 9 and 2. So that is what we've done before, and that's the answer we get. But we're not done yet, because we can extend this. Let's look at the sensitivity analysis. So let's go back to Solver. Let's solve it with a simplex linear program, make unconstrained variables non-negative, and let's click Solve and run a sensitivity analysis. Notice my answer stays the same with that new method, but now here's my sensitivity report. And so what this tells me is how sensitive are my answers. So the final value is I use 9 units of input 1 and 2 units of input 2 to minimize my costs yet still make fertilizer. All right. Well, here's the cost, 12 and 20. The question is, how sensitive is this final value to what the cost of input 1 is? Well, this tells me if input 1 increases by $1.33, or as long as it's less than or equal to 13.33, this is my same answer. If it were to increase to $14 per unit of input 1, then 9 and 2 is no longer my answer, and I'm going to go to another corner solution. Same thing here is not just an increase, but a decrease. So my final value of 2 is my objective function is input 2 costs $20. Well, if it goes down to 18, this is still the answer. But if it goes down to 17, now I have a new answer. So these talk about the sensitivity of my final answer. Lastly, we have our constraints. So the shadow price here says that if the constraint on phosphates increases by 1 unit, meaning that we now require that you have 46 units of phosphates in the fertilizer, then my cost would increase by 44 cents. If I increase the constraint of potash, meaning that I need 49 units of potash to make fertilizer, my cost will increase by $2.67. So that's my shadow price. What my allowable increase tells me is where are these shadow prices constant. So I'm currently at 45. So from 36 to 63, this is my shadow price. Outside of that range is no longer my shadow price. I get those numbers from 45 minus 9 and 45 plus 18. The same type of range. So we're going from what, 38.4 to about 60 is my range, where $2.67 is the shadow price of potash. Now for each unit increase of nitrates I need, my shadow price is 0. And that's going to go for 56 units above 84. Decrease because is going to be infinity, the same reason why we had before with the non-binding constraint, is I can require less potash, but that's not going to change my costs at all. And so that is how we go through the sensitivity analysis for example 2. So again, the final answer is 9, 2, and the sensitivity analysis tells us how sensitive our allocation of 9 and 2 is to different issues of our cost function, as well as how sensitive our constraints are.